Oy vey! Alright, hey, John Reagan with Boredbrains Consortium and Ulshe.ai. That's ULSHE.ai. And today, what I'm going to do is show you some of the kind of the pre-work that I did before I started into Polymorph. Um, I'd already been making a lot of AI architectures and systems and pipelines and stuff. And I'd found that by applying the MICT structure, the map, iterate, check, transform structure, to regular code, it actually added an additional like logical processing step. And additionally, formatting my code this way allowed me to basically take one engine, one logic engine basically, and run all kinds of programs with it because you push the program specific logic out to the app. So the engine never crashes, it never affects anything else. These all run self-contained essentially um, off that same engine. So what you're looking at right now are some basically demo apps that I did. So it's a regulatory compliance review. So it would compare based on the uh, rules of your regulatory compliance. You had a sales pipeline optimization. And then this app over here, this orange one, was essentially a delta comparison of the, and I didn't use AI for any of this. This is all just deterministic stuff. Regex. Whoa, man. That was mind bending. Is you know what? Like you work with AI and quantum and that stuff messes with your head a little bit. It like gets you thinking about things in these really broad, odd ways. But try writing some regex and getting it done right and covering everything. That'll mess your head up. I'm serious. It's just if you've done regex, you know. And if you're a killer at regex, congratulations. Oh, whoops. So, the thing I wanted to show you though here is more so the Logic Archaeologist. So, the Logic Archaeologist was something I came up with a while ago that I finally got to when they wanted to see some demo apps, and I realized I could use a MICT extractor because it's a logical problem-solving set of steps that verifies itself, essentially. Um, to extract the logic from code, documents, you name it. And so I made this tool that's not AI. It's all deterministic, and that's exactly what it does. So based off of this one right now just does code, but based off of the selection you have, and I'll show you a more advanced version of this here in a sec. You could do I have it set up for DNA code, a couple different codes right now, and different strategies that you use to parse it to put it into a MICT structure, which that MICT logic structure is essentially a logical specification. So then I can take that logical specification and use it to make any code base I need in order to make something work. Now, first of all, understand I do not use this on anyone's application code. Your application code is your application code. The only time I use this tool is for hardware drivers and stuff because hardware drivers are one of those things where the numbers are the numbers, right? Essentially, it's not as whereas your application code, because you write it, it's a copyrightable thing because it's a creative piece of work, right? The logic that goes into it is essentially logic, right? It's not anything, it's just how people think about stuff. So it's not copyrightable. It's just how you make these things operate. So that's why I'm not doing it on anyone's application stuff. I'm only doing it on the hardware because it is literally the structure of flipping the transistors and making it work. So it's not a creative thing. It's a operational thing. I already did a ton of research to make sure I was okay. So that's why. But it could. I mean, I've actually used this to deconstruct what is it? The game kernel from Quake something Arena and some other things, and It found all the security loopholes and everything, so it actually works pretty well. I was pretty impressed with it myself. So, but what I did was I took these applications and moved them to what some of you might have seen in the repos before, but you won't see anymore. Is before but won't see it anymore. Is GenesisOS, and so Genesis is a playground OS I made out of React, Rust, and if you use the where is that sucker? You got the Dojo up yet? No. So we got the Dojo. So this one you can actually select, if they're online, you can select the AIs and you can ask them questions and respond to them. But this one's more of a chat session. It's not as much of a training. Not CodeForge. Where is that thing? Dojo projects, Easy Bake, S API. Oh, Easy Bake. Better. So this one actually uses Python. And so basically I made this desktop in order to, and this is just like any work desktop you might use that logs you into a set of applications. Right now it doesn't log into my website. But some of these, like the lab and logos, which is supply chain, projects, these all draw from my website and the stuff that's running up there that, again, runs on a singular engine. All of the components do their thing and they just have their own front end logic. And then we have a single engine that runs all of the basically ERP components, right? Um, that's what this all is. This is like basically I took the stuff I made on the web and I said, okay, well, if I can make these apps on the web and I have all this back end logic that I want to put into an operating system that is deeply AI embedded, highly secure, operates in its own fundamental, very bare metal OS way, that I would need to make something like this in order to test. And so as you can see over here, I have the KMIC monitor. And so this is what I used to test all the different, what you might call for the deeper OS stuff, like the load functions, or like you see, we have system controls, we have load the core modules. This is the AI control components. We have multi-process scheduling tests that I did. It's in JavaScript, but the logic worked. And so Dojo and Ledger, this is actually how we reward the embedded AI system. You have an infinite number of coins. It's not like I'm going to charge you for tokens, right? This is in your operating system. But the AI, essentially, when it achieves its goal, or when you want to add a higher priority to something, you tell it it's worth more, right? So it has a higher OS coin value that the AI will get upon achieving its goals appropriately, right? There's a lot of stuff I put into that, like I don't want to get into it, but yeah, it gets it gets deep. And then we have the network OMSTA, checking sockets and just making sure that the firewall logic worked correctly that I'd established using MICT. And then the hypervisor components, which just staged again for putting in the PolyMorphOS as a bare metal Rust kernel. And then I did this UART stuff because I wanted to basically use this as my development front end interface when I made PolyMorphOS. And that's what I did. So as I built out, starting with BlogOS, I built out Polymorph from that base. Like I learned from doing BlogOS how the components work, how it comes together, and then went from building the BlogOS to actually expanding that into my own, not even expanding, starting from scratch to build a bare metal Rust kernel. So all these apps you see here, all these things are things that I'm going to incorporate into the Polymorph OS. So we have the lab, which gives you essentially a research type of project area, something that I like because it's a little more specific than the projects, which I see as being more like milestone and budget along with kind of resource management type thing. The lab is more like, hey, cool idea. Let's check out how it works in the science and if the math works and if these things apply. It's a little different. And then Logos is supply chain, because if you're going to have projects, you need to understand your supply chain, where your costs are, all those kinds of things. Over here we have the feed, which ties into our online community, the mice community. And then the dojo, which is really just, in this case, it's not as much training the AI in this one as it is just interacting with the AI, whether it be a single or multiple AI agents or AI models that you have running. So this is gonna, as you've already seen, some of this has already bled into Polymorph. It's already bled into the Ulshe.ai Professional Forge, the Rust library that will power AI in PolyMorphOS. So a lot of this stuff is going to come along with it. Obviously, the UI is much more, the GUI is a lot prettier and stuff here because it's React, right? It's got a lot to it. But the nice thing is, for you, the Wasm bridge that I've created, and for me in some ways, allows us to make these apps. And right now I'm working on developing the UI out more. It's a lot of rough math. And by that I mean, like, I deal with a lot of mathematical components, and I do some verification, calcs and shit. Make sure that what the AI is telling me is what's right, is what's real. And so when I do those and I try to make new stuff, it's almost like when you do JavaScript, right? And you're making these, but you realize that your box, like your flex box or whatever, is off in your dimensions, and you have to go in and just tweak it and just try, okay, that's actually a 12. 12 looks better than 20, right? Or 17 looks better than 20 or something like that. So it's weird little stuff like that, that I have to work on, and it just it's easier, but it's not necessarily easier, because unlike these things where it's essentially, a bar, and then it says put this bar here and then draw this and put this thing here, this is all literally just raw math that's being drawn to the screen directly through the rendering engine. So when you see a letter or a line in PolyMorphOS, it's not a bank of components. Like, we don't have a button like this with an X on it, right? I can put an X on it, right? I can have a button like this. Actually doing really cool things with squircles. That's sick. That's why the windows are starting to look a lot better. Just getting into making more of the shapes out of the infinity pedal, the modified Gaussian split. Yeah, I'm just so tired. I was working on the SMP stuff all night, and I'm almost at 15 minutes. I tell you, the scheduler, I got all 20 cores working, but it started breaking other stuff because of how that has to work. So I have to go in, and working with just one agent right now doing code is driving me nuts, because a little sucker takes off and does stuff, and I'm just sitting here going, watching its little output read of what it's thinking. And I'm like, no, 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 you stop. I don't even know if you changed the file yet. Oh my God. And even doing the little thing where it has to ask you for permission, it's still just not the same as like working with it to figure something out and then saying, okay, that makes sense. Okay, that's not going to break anything. Execute that plan. Honestly, it's such a bitch. But I cannot deny the fact that even with the failures, even with the bad code that it produces, or the changes and the things it deletes, right? That I have to be like, hey, what'd you do this piece of code? Where is it? This isn't going to work now. You need to put this back. We need to go back, pull it from the historicals, add it back, and make it work. And so it's tedious. It's very tedious, but it is faster, right? I cannot deny that. Like, if I was writing any of this stuff out by hand, this would be years of work, like years and years of coding, basically laid out here, in a lot of different new concepts of how to work with the hardware to really get more out of it without putting a lot of abstraction layers on top of it. Which brings me back to this. So I was getting too serious. I had to lighten up a little bit. So which brings me back to this, right? So after I got these things done and I was able to test the logic running it on a highly abstracted system such as React, right? I went and checked Rust, and it looked like, yes, I could do the same things. It would just be a lot more groundwork, as you might say, a lot more lower level systems work. And so I started working on that. And I have different ways of doing things. And so by doing BlogOS, it taught me how people were doing things there and really how the structure when you're building the OS and going through all the steps. I'd highly recommend it if you even think about doing operating systems ever at all. Go through BlogOS. I can't remember the dude's name, but thank you. You're a badass. Um, so, so what I get to with this, let me see here if I can find it. Where are we? That's the wrong one. That's the Forge. Oh yeah, I had to bow out of that one. So the Forge works great, but I have some other stuff to do there to really get it ready. Oh shit. Duh. This is how tired my brain is right now. Let me just cargo run that. It's not the dashboard. Let's see if it boots. I always love this. See, right now I've got a little hang on the SMP, and it's really annoying me. We'll figure it out here. But usually it takes like 2 or 3 tries right now. I'm gonna go back in and see what I broke or fixed. Fix some stuff, but I broke some stuff. So the reason I'm even pulling this up right now and showing you is because if you look, like before, it was resizing with the window. But if you look right now, it's not, right? And the reason it's not resizing is because it is no longer on VirtIO. It is running purely off a CPU, no GPU right now, which is a little rough for it. I mean, it's only got 4 cores, but it's handling it pretty well. I'm kind of impressed. A little slow. But using the Logic Archaeologist, I'll be able to extract the logic that I need in order to build a NVIDIA driver for it, right? I don't have any AMD equipment, otherwise I'd make an AMD one too. I already have the Vulkan driver done. So, yeah, the Vulkan driver is done. For both the Ulshe.ai Forge as well as PolyMorphOS. So PolyMorphOS will actually be, like I said, a polymorphic operating system. And that means it will be the same operating system that you run on your desktop, on your servers, on your mobile device, on your tablet. Doesn't matter. It's the same thing, right? The only difference is it might change the UI. Well, it's going to change the UI, obviously, to accommodate for your screen size, right? Going through the math so far on everything, it actually looks like all of this is going to run screamingly well on mobile devices. It just, like the way I've set everything up and the way that the transfers are and the stack processing that it does between the CPU, the GPU, and the RAM means that even on a mobile device, we're going to be able to see just crazy, crazy speeds and output. So that brings us to basically um, where I'm at now. And so, as you can see, the mouse is a little slow right now, and I'm getting a little output. But again, it's running straight off the CPU. We are free of QEMU and VirtIO at this point, so I'm basically getting everything ready to make it installable. It will be installable to devices like this, which will probably be some of my first targets because I have that. And then I have this Razer 2 phone that I just love this thing, and it's big and chunky. And I think it'll help a little bit with kind of the UI aspect. Like if I turn it like this, it could be this desktop you see. But if I turn it like this, then maybe this goes over here, it gives you little readouts. But the neat thing is, because it's polymorphic, because it's just it's I don't say base math, but because it's just number sets and no image processing that it's doing, it'll run screamingly fast on a cell phone. We can design it to actually self-adjust all of the windowing and all of the design. So what we get to is a UI that, based on the device you're on and what application and what function you want, will adjust itself, basically creating the UI on the fly, right? So let's say, for example, you tie into some weather service, right? Like, okay, I do weather.com, right? And then instead of seeing weather.com's UI, because your AI on your phone knows you and knows what you like and knows how you like things presented, it may adjust it slightly. It may change it so that the things that are important to you come up at the top in the display, and the things that are usually less important to you, like maybe you don't have allergies or something. Like for me, I'd want that right at the top. Humidity, allergy info. Well, we got grass. Oh, high humidity. Why? This is Vegas. So, oh man, I feel good today though. I can breathe. So yeah, so essentially the UI can adapt and adjust everything that comes into it. It can give you things that are much, much more personalized, while at the same time not invading on your privacy. And that's the overall goal for me. So if you want to engage and you want to have people taking your ad info for services you do online for free, that's up to you. All right. I don't believe in it. I think that, there's enough opportunity out there for all of the ad companies to be getting your information without actually having to take your information, if you know what I mean. So anyway, I digress on that point, and we're at 21, so I'm gonna bounce. But great news, we are off. Oh, Control G. Even though it doesn't look great right now, we're on the UEFI buffer. So once I get this GPU driver done, yeah, we'll actually be able to support larger screens, displays, higher definition, blah 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 blah. So, and I know a bunch of you are like, "Oh, this is gonna be hard, John. We'll talk to you in like next year. I'll talk to you in 2030." But like I said, the Logic Archaeologist, which I just kind of finalized out a little bit more of getting it to, where'd you go? Oh yeah, I had to restart it. So this little guy right here, this one's pretty cool. This is like the most advanced one I've made so far. So basically, you drop in, right? You got C+, Polyglot, and Mnemonic DNA. I don't have another one in here somewhere. I gotta load that one in there. Anyway, choose your file, whatever it is, your JSON or whatever, your code, whatever you have. Drop it in here. It creates a data dictionary. Over here, it creates the logical flow. And then in here, it actually shows you a nebula. It's not quite working right. It's a little chunky still. I want to get it going. But it shows you a nebula of how the data interconnects with the other data, where it verifies, and then where it goes out of the stream. So it gives you a really cool visual for your data. I thought that was neat. That's something from working with the neural network shit. So anyway, that's my little bit. We're at 23, so I'm going to give you guys like bye bye, you know. Not that any of you probably watch this anyway, but but yeah, so basically I've used MICT as a, you might call, coding format to reduce my overall code sizes, as well as isolate them so that if one breaks, it doesn't break another. I started here with the React version called GenesisOS that turned into what we now know, or what some of you may now know, as PolyMorphOS. And obviously it doesn't look as good because I got to build the UI from scratch. Cut me some slack. It's not my usual thing. So anyway, y'all have a great, what is it, Thursday. Have a great Thursday. All right, have fun. Be good to each other.